Okay, moving on to the Adept video. In this video we're actually going to calculate some slopes. So recall in the previous video I defined the slope three different ways. First of all, physical. It's just the rate of change. So it's how quickly or how slowly something is changing. Graphically, it is the vertical change in y as x changes horizontally. Well, how do we put the two together? We divide them. So in the algebraic definition, it's just the vertical change in y, or delta y, divided by the horizontal change in x. Okay, and we used delta y over delta x. Okay, now you'll often hear this: rise over run. What does that mean? Well, delta y is often referred to as the rise, because a change in y, that is a vertical change. So that tells you how far up or how far down the line is going. So that's often referred to as the rise. Delta x, or change in x, that tells us how the graph is changing as we go from left to right. So that is often referred to as the run. So ideally, when you see the word slope or hear the word slope, automatically in your mind you should think rise over run. Okay, so let's actually calculate some slopes. So I've divided it into three parts. The first part, use the 2 points that are given and calculate the vertical change in y, starting at the leftmost point. Part 2, just repeat that process, but we're going to determine the horizontal change in x. And then part 3, we're just going to put them together and we're going to divide one by the other, and that gives us our slope. So let's try it. Alright, so in this first graph, the 2 points that are given are here and here. So we want to calculate what is the vertical change. Okay, so we don't care about what's going on left to right, just how far up or down. So it says to start at the leftmost point, so that'd be here. So in order to get from this point to this point vertically, we would have to go up 1, 2, 3, 4, 5, 6, 7, 8, because we are now at the correct height. So delta y is 8. Specifically, positive 8, because we had to go up. Now we want to figure out the change in x. Okay, so starting at the leftmost point, so to get to this point horizontally, we go 1, 2, 3, 4, 5, 6, 7, 8. Okay, that lines up there. Specifically, positive 8, because we went to the right. And slope was defined as whatever delta y is, my rise, divided by delta x, which is my run. So that is 8 divided by 8. As a fraction, that's very nice. It reduces to 1. So therefore, this line has a slope of positive 1. And I'll just throw this in here. Just some dashed lines so you know how I was shifting here. That's a 90-degree angle. Just erase that a little bit. There. Okay. Alright, so that's the slope of the first line. Let's try the next one. Okay. Let's first determine from one point to the other, what is the vertical change? So to go from this point to this point, we obviously have to go up. So it should be positive. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That would get us there. So my delta y is positive 12. Alright, what's my delta x? Right, well, to get over here to my desired point, I just go 1, 2, 3, 4. That's 4 spaces to the right. That's a 90-degree angle. So my delta x is positive 4. Alright, so my slope, delta y over delta x, is just 12 divided by 4, which is 3. Okay? Alright, So let's compare these numbers. This had a slope of 1. This has a slope of 3. 3 is bigger than 1, and if you look at the picture, it's clear that this line is steeper. Okay, so just by pattern recognition, it would make sense that the steeper the line is, okay, at least so far, would indicate that this number should be larger. All right, let's try another one. So we're here. Let's figure out our vertical change. Okay, so we're going to go up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 again. Okay. Positive because we're going up. And horizontal change. 1, 2, 3, 4, 5, 6, 7, 8. And we're moving to the right. Again, that's a 90-degree angle. So therefore, the slope of this line is 12 over 8. Now, unfortunately, we're not going to get an integer as an answer, but we always reduce fractions whenever possible. Okay, and you should be familiar with reducing fractions. So the greatest common factor between 12 and 8 is 4. So we just divide both the top and bottom by 4. So that gives us 3 over 2. Okay, so the slope of this line is 3 over 2. As a decimal, which you don't need to do, but that's equivalent to 1.5 or 1.5. Okay, so we can see here that slopes can be decimals. Okay, so starting at the leftmost point, that would be here. Okay, well in this case, our vertical change, we're actually going down. So if we're going down, the number is actually going to be negative. So delta y, we have to go down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that's a change in y of negative 11. Okay. So I'll just put that in here. Okay, and our delta x, okay, well we have to go to the right, so that is positive. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, well our slope is rise over run, so delta y over delta x. So we get negative 11 over positive 11, and that simplifies to negative 1. So I'll just put that in there, 90 degrees. Okay, so we have a line with a negative slope, and if you look at how this line differs from the previous 3 lines, you'll notice that this line from left to right, it is going down. Okay, so slopes can be positive or negative. So if a line is going down as you go from left to right, your slope is going to be negative. Okay, so just looking at this one already, without doing any number crunching, any calculation whatsoever, okay, we should be able to tell just by looking at this that the slope is going to be negative, because from left to right the graph is going down. So let's verify that. What's our vertical change? Okay, well, our leftmost point is here, so we have to go down 1, 2, 3. That's down. So whenever you go down, it's negative. If you go up, it's positive. Horizontally. Okay, well, let's put that in there. Then I have to go, let's count. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's to the right, so it's positive. So my slope is negative 3 over 12. Okay, that's a reducible fraction. So the answer to that is negative 1 over 4. Okay, on an exam or any textbook, a negative fraction is almost always written like this. They'll just put the negative in front of the whole thing. Okay, but we can see that it is negative because it is going down. But it's a fraction. Okay, it's a proper fraction. And notice how this line is quite shallow. All right, last one. Well, this one's a bit different. Okay. Well, let's see if we can use some common sense. If you were to invent a system that was to measure the steepness of a road, and your road was completely flat, what number would you assign a slope of a flat road? I think you'd probably say, well, it has no steepness, so the steepness should be 0. So let's see if that actually works. Let's see if the convention has some logic to it. So from this point to this point, what's the vertical change? Well, there is no vertical change. Okay, I neither go up nor down. It stays the same. So the horizontal change is 0. Okay. Sorry, the vertical change is 0. But the horizontal change, okay, I go 1, 2, 3, 4. 4 spaces to the right. Well, at this stage, I don't care how many spaces to the right I go, because delta y divided by delta x. Well, what's 0 divided by 4? What's 0 divided by anything except for 0? That's 0. So lo and behold, if we have a line that is perfectly horizontal, the slope is 0. Hence it's flat. So just to summarize, if the line from left to right is going down, the slope is going to be negative. If the line is going up from left to right, the slope is positive. And if the line is perfectly horizontal, the slope is 0. So there's a brief introduction to slopes, and you'll work with slopes a lot more in the next chapter.